Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this channel, I am covering the entire syllabus of IGCSE Cambridge Chemistry and the course code is 0620, and this is our seventh and last lecture of chapter 2, which is about bonding and stuff. So this is 2.7 metallic bonding. So for core students, this is not included in their syllabus. This is only for students who are preparing for extended syllabus or supplement. So which will be attempting paper 4. So the first topic, like if you are not registered for supplement, so you can skip this since this lesson is only for the students who are registered for paper 4 extended. Okay, so this topic has two subtopics. The first one is describe the metallic bonding as the electrostatic attraction between the positive ions in a giant metallic lattice and a sea of delocalized electrons. So in this lesson, we will be focusing on what metallic bonding is. So you can see this diagram. Let's say we have a piece of sodium, for example. So you can imagine, like we have studied that in solids, the particles are closely packed and they have very high intermolecular forces. They're held together very tightly. So let's say this is sodium, which is an element, a pure substance. So all these elements, they will belong to sodium atom, right? All these atoms, they will have 11 protons and 11 electrons because the atomic number of sodium is 11. So now, how basically these atoms are connected, with each other? That is the main question, because in ionic bonding, we saw that when a metal and a non-metal joins together, for example, NaCl. So sodium, it loses an electron from its outer shell. It loses one electron because it is in group 1, and chlorine, it gains that electron. So in this process, they get positive and negative charges, and they're held together by electrostatic forces of attraction in a giant crystal, a giant ionic structure, right? But and again, I'm doing a comparison between these three types of bonding, like ionic, covalent, and metallic, so that you can understand metallic bonding much better. So in a covalent bonding, we saw that we have a metal, we have two non-metals, and they share electrons, right? If you go back and watch our lecture on covalent bonding, where we have practiced the dot and cross diagrams, so you will see that electrons are shared between the two different atoms, right? So now in metals, since all the atoms are the same, so how are they joined together? So this is basically what we are trying to understand in metallic bonding. So what happens is that we are already aware of the tendency of metals to lose electrons. So I'll imagine these layers, like these are the layers. So this is the first layer and second and third, for example. So each layer is going to lose the electrons to the upper layer, right? So but since all the atoms are the same, none of the atoms are, they are ready to accept these electrons. So I repeat, what happens is that, each layer is gonna lose electrons to the layer above, and because the since and by losing that electron, they can have a complete outer shell, but these electrons are not gained by any of these metal atoms, right? So they just exist like between these interatomic spaces in the solid structure, and these electrons are called sea of delocalized electrons, right? So this is basically how we explain metallic bonding. And now you can see that a polarity is created, you can see that this electron, negatively charged electron, will be attracting this positive ion, and positive metal ion, or the positive metal cation, and these are called. And the electrons in the outer shell of metal atoms are delocalized, and they are free to move through the whole structure. And yeah, so this is how basically they start attracting each other, and the force of attraction between them is called electrostatic force of attraction. Electrostatic force of attraction, or electrostatic attraction, which exists between positive and negative ions. But here we have cations and C of delocalized electrons. So most students, they make mistake, and when they explain the metallic bonding, they say that there's an electrostatic attraction between the positive metal cations and negatively charged ions. There are no negatively charged ions. Remember that it is just the C of delocalized electrons and positive metal ions, or we can also say metal cations, right? So this is basically what metallic bonding is. Now we move on to the next topic, which states that explain in terms of structure and bonding the properties of metals, good electrical conductivity. So I've explained it already in our previous lectures. You can go to the playlist and watch the previous lectures, so that you can understand it better, and you can have a very good understanding, overall understanding of chemistry. So anything that will conduct electricity must have delocalized electrons or ions that can move. So in this case, since we are studying about metallic bonding, so we have C of delocalized electrons. What do we mean by C of delocalized electrons? These are the electrons that can move freely in between these interatomic spaces, and that is how they conduct electricity. And now malleability and ductility. So what is meant by these two terms? Malleability means the hammering property. So the ability of something to be able to convert it into sheets, thin sheets. Like for example, aluminum. For example, you like we use aluminum foil for baking and packaging purposes. So that is aluminum, literally turned into such a thin sheet, right? So that is malleability, the ability of something to be able to change into paper-like structure, right? So thin. And what is meant by ductility? Ductility means the ability of something to be able to stretched in wires. For example, copper. So copper, you see, wires, you know. So if you look inside a wire, like don't try this at home. Only a supervised teacher, or your supervisor must show you this. So an electric wire which is not connected with an electric socket, so your teacher will peel off the covering, and it will show you the copper inside. So that is so thin, right? So copper, being a metal, it has this ability that it can be stretched so thin, and it can be changed into long wires, right? So that is why now why or how does this property can be related to this structure? So let me explain. So when a force is applied here, like let's say if you are hitting it with something or stretching it, since ionic bonds, or like these electrostatic forces of attraction, not ionic bonds, I'm sorry, so these are non-directional, right? So since these are positive and negative ions, so they can attract each other in every direction. So even if a force is applied, so they don't shatter. They hold on to each other, and they don't let other atoms to shatter, or break off. So they keep on holding together, and they change their shape. And when the effect of that force is distributed along this structure, so the structure will change its shape, but it will stay intact, right? It will remain, they will be holding on to each other even after force is applied. So just because these layers can slide over each other, these like metals, they don't shatter, like a piece of charcoal, for example, which is a non-metal, and which doesn't contain metallic bonding. So if you throw a piece of charcoal, which is basically carbon, so you will see that it will shatter like a stone made of clay or something. So, but if you drop a piece of metal, so it will retain its shape. There will be a dent, uh, you know in the structure, if you drop it from a height, but it will not shatter, right? So this is why basically metals can be they can show malleability and ductility. And they also have very high melting and boiling points, because these electrostatic forces of attraction, these are very strong between the positive metal cations and sea of delocalized electrons that carry a negative charge. So a large amount of energy is required to break them. So I hope I've explained it enough and you understand this. So now we can move on to some questions from the past papers, so that you can understand it more effectively. And you can see that what type of questions they ask you on this topic. So the first question is this question is about, and this is from paper 4, because this topic is not included in paper 3 or the core. So this is from extended. So this question is about sodium and compounds of sodium. A1, describe the bonding in a metallic element such as sodium. You may include a diagram as part of your answer. So you can draw this same diagram, which is here, and you can show positive metal ions, and you have to label them as well, right? So these must have positive charges like this, and then in between these spaces you can draw sea of delocalized electrons, right, like this. So and then it will be considered correct. Okay, and you can say that this question has 3 marks. So you can say that in metallic bonding we have positive ions, and sea of delocalized electrons, sea of electrons or delocalized electrons, and there is attraction between positive ions and electrons, and they attract each other, right? This is how you can structure your answer in order to get. So when you write positive ions, you're gonna get 1 mark, and when you use this keyword sea of delocalized electrons, you're gonna get another mark. And the 3rd mark will be awarded when you say that there is attraction between positive ions and electrons. So this part is going to get you the 3rd mark. Okay, next question. Describe how solid sodium conducts electricity. So you can, it has 1 mark, so you can say that electrons can move. So electrons flow or electrons can move. So next one is potassium is a group 1 element. Name and describe the bonding in potassium. So what since potassium is from group 1, so group 1 and 2 and 3 they are metals. We have already talked about this. So bonding will be metallic. And description, 4 marks. Okay, so again, like you say that a metallic bonding will have a lattice, like a lattice of potassium ions. So in metallic bonding, we have like metallic bonding in sodium, right? We have a lattice of potassium ions. This sentence is gonna get you 1 mark, and metallic bonding will get you another 2. And C of delocalized electrons. C of electrons is also sufficient. You don't have to write delocalized, but use it to be on the safe side. So use C of delocalized electrons. Which which attract potassium ions. Or you can say that to structure this sentence accurately, we can say that and C of delocalized electrons, and there is attraction, between potassium ions and electrons, right? So this is going to get you another mark, right? So these are the 4 marks. So this is how you answer questions on like a metallic bonding. The topic is 2.7, and yeah, I guess that's it. So I also offer one-on-one lessons. If you need one-on-one lessons, you can fill out this Google form given in the description, and you can also join my school community, high school chemistry on school.com, which is free. You can join. You can interact with other students like from all around the world studying high school chemistry. And if you wish to join group lessons, I offer 4 lessons in a month, once per week. So for that, you can join my premium package that is available on school.com in that community. So like, subscribe, and share. This will be all for today, and I'll see you in the next lesson where we will be starting stoichiometry, the 3rd chapter. Okay, see you in the next one. Take care. Goodbye.